Hi, this is Mark. Today we're going to take a look at getting started with Oracle Vector Store support in LangChain. I'm going to be using Visual Studio Code with the Python and Jupyter extensions from Microsoft already installed. So we're going to start by creating a new Jupyter notebook. So I'm going to say getting started interactive Python notebook. And I am going to create a cell and install some prerequisites. So I'm going to create a code cell and paste in this pip install command here. Actually, the first thing I have to do is select the kernel. So let me pick select kernel, and I want to create a Python environment. And I'm going to create a virtual environment, a venv, and I'm going to use Python 3.12. You should use 3.11 or later for this to work well. You can see it's installing some of the necessary packages here. And when that is done, we can now go ahead and run our cell. So this is going to install the OpenAI support for LangChain. This will just take a few seconds to run. Okay, and now that that is done, I am going to set up my OpenAI API key. So let me copy this code in here. I'm going to create a new cell, a new code cell, and paste this code in. So this is just going to basically check if I have an environment variable set, which I don't. And if not, it's going to prompt me to enter my API key. So let me go ahead and run that. And you see it is prompting for my OpenAI key, so I'm going to paste that in here. And that is done. That's saved now. So the next thing we're going to do is just ask the model a question to make sure that's all working. So you can see I created a model object here for GPT-4o Mini. So let me create another code cell. I'm going to paste in. So this is just going to send hello world to the model as the prompt. And I should get back a response that includes a message. So here I have hello, how can I assist you today? You see I have some other stuff like metadata and so on that gets returned from the model. Okay. So the next thing that we want to do is start up an Oracle database so that we can create our vector store. So I have already done this. I have my database running. And I am going to create a user called vector and give it the appropriate permissions to be able to create the vector store and everything that we need to do. So let's paste that command in here. So it's going to create a user called vector, and it's going to give a few permissions to that user. Okay, so you can see that that was successful. Okay, so the next thing we're going to do back in our notebook is install the Oracle database dependency. So let's copy this code into here. I'm going to create a new code cell, paste this in, and we'll run that. Okay, so that is done. Now we are going to connect to the database. So let's copy this block of code here. I'll create a new code cell and paste that code in. So here we're saying import the Oracle database library, and our username and password are vector, and here's our connection string for the database. So we're going to try to connect to the database using these details. If that is successful, we are going to store our connection in this connection variable and print out a message. If we get any problems, we're going to print connection failed. So let's go ahead and run this. Okay, connection successful. So we are connected. Okay, so now let's go ahead and install some of the dependencies that we're going to need to use the vector store and the models and so on. So I'm going to copy this block here, and I'm going to create a new cell, paste that code in here. I'm going to run this. So this is installing the LangChain community library, which has the Oracle vector store support and support for lots of other vector stores as well. And also the Hugging Face library, which allows us to use embedding models from Hugging Face. If you're not familiar with Hugging Face, it is a website that has many models and data sets and all kinds of resources for working with generative AI available. And okay, that finished installing. So let's go on to the next step. So now we are going to import the various things that we're going to need to work with the vector store. So let's copy this piece of code. And I'm going to create a new code block and paste this in and run it. Okay, so we've done those imports. And now we are going to need some documents to load into our vector store. So now in real life, we probably would actually use some Office documents or PDF documents or maybe some documents on the web. But for the purpose of this example, to keep it simple, I'm just going to use a few small pieces of text. So these are actually taken from the book Moby Dick. So I'm going to copy these and jump back over to my notebook, and I am going to paste this in. So you see I have 3 documents here. Each one has a link to the source on the web where I took these from. It has the text and it also has a identifier. So let me run this. This is just creating a Python dictionary. Okay, and now we need to load them into a LangChain document list. So let's copy this piece of code here. And I'll create a new code block and paste that in. So here we're going to create a new array, and for each document in this list that we had, dictionary list that we had here, I'm going to just create metadata and create a LangChain document and put in the text and the metadata and then add that into our list. So let's go ahead and run that. Okay, and that is done. Okay, so now at this point, let's actually take a look in our database. Actually, no, sorry, I jumped ahead one. At this point, let's go ahead and create our vector store. So I'm going to copy this code block here. And I'll create a new cell and paste this in. So here we are going to load an embedding model from Hugging Face. We're going to use the sentence transformers all MPNet base v2 model to create our embeddings. And here we are going to create an Oracle vector store from a list of documents. And the documents we're passing in are the ones that we created earlier, the Moby Dick paragraphs. So we're passing those in here. The model we're going to use to create the embeddings is this one right here that we're going to get from Hugging Face. Here's our database connection. And we're going to call our table in the database documents cosine. And the distance strategy that we're going to use is the cosine similarity strategy. Of course, there are a number of different algorithms that you can use, like Euclidean and Manhattan and so on. Cosine is particularly good for text, so we're going to use cosine as our distance strategy. So let's run this. Okay, so now this is actually creating embeddings from those documents and loading them into the database. Okay, so now let's take a look and see what actually happened in the database. So I'm going to copy this code block here. And I'm going to paste that in here. And we'll run that. So you can see this is doing it's going to show me the tables that I have created. It's going to describe the document cosine table that we created up here. Then I'm just going to do a select star from documents cosine with a little bit of formatting here to make the output a little bit easier to read. Okay, so let's just scroll back and take a look. So we can see we connected to our 23AI database. Here's our table, documents cosine, the one we created right there. You can see that vector store table has an ID column, a text column, which is a character large object, which contains the actual raw text. We have the metadata column, which is a JSON document. And we have the embedding, which is the actual vectors. And here you can see this is obviously truncated, but this shows you the rows in the table. So you see the ID, the text, the metadata as JSON, and the first part of the vector embeddings that were created. Okay, so our table is all populated and ready to go. So the next thing that we are going to do is try a vector search. So let's copy this statements here. We will jump back over to our notebook, create a new cell. So I'm going to do two queries. First, I'm going to ask, where is Rocovoco? And I am going to do a similarity search in the vector store that we created. And this one here means I want the one closest match. I could put 2, 3, 4, however many matches I want, but one is going to give us the closest match. And then second question I'm going to ask, what does Ahab like to do after breakfast? So let's go ahead and run this. And I called it vector store max. So let me just go ahead and fix that. Vector store max. Okay, let's run that again. Okay, so you see the result from the first query. Where is Rocovoco? I got a document back. You can see there's the link, and it says, Queequeg is a native of Rocovoco, an island far away to the west and south, and it is not known on any map. True places never are. So that is, in fact, the closest of the documents that we loaded here. That was this first one. Then for the second query, I got this P2 document. It was not great while after the affair of the pipe that one morning, shortly after breakfast, Ahab, who was the captain of the Pequod, as was his wont, ascended to the cabin gangway to the deck and so on. And again, you'll see that is actually this segment that we had here, and that is actually the most appropriate for the question, what does Ahab like to do after breakfast? Okay, so that is it. We created a vector store, we loaded some documents and embeddings, and we did some vector searches, and that is like the very most basic example of using a vector store, an Oracle vector store from LangChain. So stay tuned to learn more about more advanced features like indexes and different kinds of search algorithms and filtering with security rules and all kinds of other stuff. If you're interested in learning a little bit more and you don't want to wait until I get around to publishing more posts and videos, you might like to check out this article from my colleague Doug, who goes a little bit further and actually shows you a bunch more stuff that you can do with the Oracle Vector Store. So if you're a little bit anxious to find out more sooner, then you might like to check out this post. Otherwise, I will see you next time. Thanks.